Welcome to Computer Networks, Networking Hardware Devices. After watching this video, you will be able to identify common networking hardware devices, list differences between similar network devices, and explain the significance of each type of network device and its functions. Network devices, or networking hardware, are physical devices that enable communication and interaction on a computer network. This includes cables, servers, desktops, laptops, tablets, smartphones, and Internet of Things, or IoT devices. This video covers network devices that connect or route, such as hubs, switches, routers, bridges, and gateways. A server is a powerful computer that stores files and applications. Other computers or devices on the same network can access the server as a central place to store information or use applications. The devices that access the server are known as clients. The server controls the level of access that clients have. A user can access a server file or application from anywhere if they use a client that is connected to the server's network and has the proper level of access, usually password-based. A node is a network-connected device that can send or receive information. A client is a node that accesses the network through a server. All devices that can send, receive, and create information on a network are nodes. The nodes that access servers to get on the network are known as clients. The server controls the level of access that clients have. If a client fails, the network remains unchanged. Client-server networks are common in businesses. They keep files up to date and easy to find by ensuring users work on one shared file in one location. Examples of services that use client-server networks include file transfer protocol sites, or FTP sites, web servers, and web browsers. Peer-to-peer networks are common in homes and on the Internet. Peer-to-peer networks allow users to share resources and information. Examples include file-sharing sites, discussion forums, media streaming, and voice-over IP services, also called VoIP services. A hub connects multiple devices together in a network. When data is sent to a hub, it broadcasts that data to all devices on the network, except for the one that sent the data. A switch is similar to a hub, except it keeps a table of MAC addresses. When a switch receives any data, it looks up the proper MAC address and forwards the data to the right place. Switches are more efficient than hubs because they only send data to the intended recipient. Switches and hubs connect to modems. If a switch or a hub fails, it brings the entire network down. Routers interconnect different networks or subnetworks. A router serves two primary functions. They manage traffic between networks by forwarding data packets to their intended IP addresses, and they allow multiple devices to use the same Internet connection. Routers connect to modems. To direct packets effectively, a router uses an internal routing table, which is a list of paths to various network destinations. The router reads a packet's header to determine its path, consults the routing table to figure out the most efficient path, then forwards the packet to the next network in the path. A modem, or modulator-demodulator, converts data into a format that is easy to transmit across a network. Once that data reaches its destination, the receiving modem converts it back to its original form. The most common modems in use today are cable and DSL modems. A bridge joins two separate computer networks so they can communicate with each other and work as a single network. Bridges can be wired or wireless. Wireless bridges can support Wi-Fi to Wi-Fi, Wi-Fi to Ethernet, and Bluetooth to Wi-Fi connections. A gateway is hardware or software that allows data to flow from one network to another. For example, a home network to the Internet. Gateways are distinct from routers or switches in that they use multiple protocols to connect multiple networks. A repeater, or extender, receives a signal and retransmits it. Repeaters are used to extend a wireless signal so it can cover longer distances or be received on the other side of an obstruction like brick, steel, or concrete. Repeaters connect to wireless routers. A wireless access point, also known as WAP or AP, allows Wi-Fi devices to connect to a wired network. The WAP usually connects to a wired router as a standalone device. The WAP can also act as a central wireless connection point for computers equipped with wireless network adapters. The WAP is plugged into a wired network switch. The WAP reads each computer's MAC address and forwards that to the wired switch. If the wired network is connected to a router with Internet access, the wireless network will also have Internet access. Network interface cards, or NICs, connect individual devices to a network. NICs can be wired or wireless. Today's computers usually come with wireless NICs already built in. Most include ports for network cables, so users can easily connect their computer to a network. A firewall monitors and controls incoming and outgoing network traffic based on predetermined security rules. A firewall typically establishes a barrier between a trusted internal network and untrusted external network, like the Internet. Firewalls can be either software or hardware. Wireless routers and computer operating systems often have built-in firewalls. A proxy server acts as an intermediary between a LAN and the Internet to minimize security risks. The proxy server evaluates requests from clients and forwards them to the appropriate server if those requests meet preset security requirements. Proxy servers hide an IP address. If an IP address is hidden, it cannot be tracked. Proxy servers save bandwidth. For example, a proxy server will download files or updates for the first user, then keep them stored for any future users who need them. An intrusion detection system, or IDS, monitors network traffic and reports malicious activity to the network administrator. An intrusion prevention system, or IPS, inspects network traffic and removes, detains, or redirects malicious items based on rules set by the network administrator. In this video, you learned network devices, which can be a variety of different types, enable communication and interaction on a network. Servers are powerful computers that store files and applications and are accessed by other computers on the same network. Nodes and clients can be configured in different ways. Routers and modems transmit and convert data to ensure interconnections happen and information reaches its destination correctly. And firewalls, proxy servers, IDS, and IPS work to keep networks secure. Welcome to Computer Networks, Models, Standards, Protocols, and Ports. After this video, you will be able to explain networking models and standards, list the role of each protocol type, and define common ports. A networking model describes the architecture, components, and design used to establish communication between the source and destination systems. Data packets follow the protocols of network models. There are two types of networking models. The OSI, or Open Systems Interconnection Model, is a conceptual framework used to describe the functions of a networking system. The TCP/IP, or Transmission Control Protocol Internet Protocol Model, is a set of standards that allow computers to communicate on a network. TCP/IP is based on the OSI model. The OSI model is a conceptual framework used to describe the functions of a networking system. Data flows across these layers when communicating over a network. The 7 layers of the OSI model include application. Users and applications interact directly with the software application. Presentation. Ensures that data is in a usable format and is where data encryption occurs. Session. Controls the flow of information between different computers, including authentication and reconnections. Transport. Manages the delivery and error checking of data packets. Data is commonly transported using Transmission Control Protocol, or TCP. Network. Responsible for interpreting the addresses and directing the path the data will take. Data link. Defines the format of data on the network. This layer also corrects errors that may have happened at the physical layer. And physical. Electrically or optically transmits raw, unstructured data over a physical medium. The TCP/IP model is a set of standards that allow computers to communicate on a network. TCP/IP is based on the OSI model and functions similarly. The background protocols are still in place, but the way they are organized is slightly different. The data travels through fewer layers on both ends. Networking standards define the rules for data communications that are needed for interoperability of networking technologies and processes. Standards are widely accepted protocols that engineers use to make sure the things they build integrate with existing devices and technology. There are two types of network standards. De jure, or formal standard, are formal standards developed by an official industry or government body. Formal standards have gone through formal processes to obtain consensus, including publicly available documentation. Examples include HTTP, HTML, IP, and Ethernet 802.3d. De facto standards result from marketplace domination or practice. De facto standards are accepted in practice but have not undergone any formal process to obtain consensus and may not have publicly available documentation. Typically, de facto standards result from marketplace domination or practice. Examples include Microsoft Windows and QWERTY keyboard. Standards are usually created by government or nonprofit organizations for the betterment of an entire industry. This ensures a broader compatibility across vendors and industries. Some of the well-known organizations that have created network standards are International Standards Organization, or ISO, established the well-known OSI reference networking model. International Telecommunication Union, or ITU, standardized international telecom and set standards for fair use in radio frequency. Defense Advanced Research Projects Agency, or DARPA, established the TCP/IP protocol suite. Institute of Electronics and Electrical Engineers, or IEEE, established the IEEE 802 standards. The World Wide Web Consortium, or W3C, established the World Wide Web, WWW, standard. Finally, the Internet Engineering Task Force, or IETF, maintains the TCP/IP protocol suites. IETF also developed the Request for Comment, or RFC, standard. A network protocol is an established set of rules that determine how data is transmitted between different devices in the same network. Network protocols are typically created according to industry standards. There are thousands of different network protocols, but they all perform one of three primary actions: security, communication, and network management. Transmission Control Protocol, or TCP, and User Datagram Protocol, or UDP, are two primary Internet protocols. TCP guarantees sent data makes it to its intended recipient. It's slower and requires more resources. File Transfer Protocol, or FTP, web browsing, and email are typical applications of TCP. UDP doesn't guarantee all packets will arrive, but it's fast and needs fewer resources, good for live streaming, online gaming, and calls over the Internet. The TCP/IP suite is a collection of protocols. Together, these protocols provide a complete networking solution. The Internet of Things, or IoT, network model comprises diverse protocols for communication, which include data collection, data package, data transfer, and data control. The Crypto Classic protocol is designed to serve as one of the most efficient, effective, and secure payment methods, built on the blockchain network. It ensures privacy and transparency of payments directly transferred between two parties who have an address on the blockchain network. Ports are the first and last stop for information sent across a network. A port is a communication endpoint. A port always has an associated protocol and application. The protocol is the path that leads to the application's port. A network device can have up to 65,536 ports. Port numbers do not change.
A socket is a two-way communication channel. Each socket is made up of a source IP address, a protocol, a port number, a destination IP address. You use a socket whenever you send data over your local network or over the Internet. For example, whenever you use a web browser, send an email, or watch a video online, a socket is used over the network in order to make that communication possible. In this video, you learned that network models in OSI and TCP/IP describe the design used to establish network communication. Network standards define the rules for data communication and ensure broader compatibility. Network protocols are based on an established set of rules for data transmission.
Welcome to Computer Networks, Wireless Networks and Standards. After watching this video, you will be able to explain the different wireless network types, list the advantages and disadvantages of each wireless network type, and describe the wireless networking standards. As an alternative to traditional cable and fiber optic networks, wireless networks have become crucial for enabling mobility. Wireless networks like WPAN, WLAN, WMAN, and WWAN use radio waves for data transmission and reception instead of wires. And they follow IEEE wireless standards. These are the sets of protocols that define how all wireless communication works. This video describes how wireless networks function and what each one is used for. A WPAN connects devices within the range of an individual person, around 10 meters. WPANs use signals like infrared, Zigbee, Bluetooth, and ultra-wideband. WPANs use the IEEE 802.15 wireless standard. Bluetooth and Zigbee are some of the IEEE 802.15 signals that wirelessly connect devices over short distances. Advantages include flexible and efficient, one-time easy setup, and portable. Disadvantages include limited range, limited data rates, and more expensive. A WLAN connects computers and devices within homes, offices, or small businesses. WLANs use Wi-Fi signals from routers, modems, and wireless access points to wirelessly connect devices. Wi-Fi follows the IEEE 802.11 wireless standard. The latest version of IEEE 802.11ax enables 8K video streaming, data-heavy cloud computing, and virtual reality experiences. Advantages include reliable and versatile, high data transmission rates, and easy to manage. Disadvantages include low network coverage area, number of devices affects speed, and less secure. A WMAN spans a geographic area. It serves ranges greater than 100 meters. Worldwide Interoperability for Microwave Access, or WiMAX, is a family of wireless communication standards that provide WMAN broadband connectivity. There are similar open source and proprietary broadband technologies, but WiMAX is the accepted suite of standards based on IEEE 802.16. Advantages include covers multiple city locations, easy to use, extend, and exchange, and managed by an ISP, government entity, or corporation. Disadvantages include require special user permissions, less secure, and slower than wired. A WWAN provides regional, nationwide, and global wireless coverage. This includes private networks of multinational corporations, the Internet, cellular networks like 4G, 5G, long-term evolution, or LTE, and LoRaWAN, which is a low-power WAN protocol built on top of the techniques used in long-range radio modulation. Advantages include global wireless coverage, better security than WLAN, and centralized flexible infrastructure like cloud apps and storage. Disadvantages include expensive, difficult to maintain, and decreased coverage over large areas. A wireless ad hoc network, or WANET, uses Wi-Fi signals from whatever infrastructure happens to be available at the time to connect devices instantly, anywhere. WANETs are similar in size to WLANs, but use technology that is closer to WWANs and cellular networks. Advantages include flexible, no required infrastructure, and can be set up anywhere instantly. Disadvantages include limited bandwidth quality, not robust, and has security risks. There are also MANETs, or mobile ad hoc networks, and VANETs, or vehicle ad hoc networks. These are similar to WANETs but have different specifications. A cellular network provides regional, nationwide, and global mesh coverage for mobile devices. Each version below represents a cellular network evolution. 2G supported digital voice and simple data with 64 kilobits per second speed. 3G supported mobile broadband with 2 megabits per second speed, which enabled basic GPS, media downloads, and streaming. 4G advanced speeds and efficiencies with 100 megabits per second speed. And 5G brought 1 gigabits per second speed, which is still bringing cellular networks to a whole new level. Advantages of cellular networks include flexibility, access, and speed and efficiency as it evolves. Disadvantages include expensive, decreased coverage in rural areas, and hardware limitations like screen size and mobility of peripherals. The IEEE 802.20 and IEEE 802.22 network standards support WWANs, cellular networks, and WANETs. Well-known use cases include emergency mobile operations, internet on airplanes, internet service provider networks, and large-scale monitoring for things like earthquake zones, flood warnings, and space exploration. IEEE 802.20 uses smart antennas to optimize bandwidth for increased coverage or mobility. It is no longer being actively developed, but it is still used to fill the gap between cellular and other wireless networks. IEEE 802.22 uses empty spaces in the TV frequency spectrum to bring broadband to low-population, hard-to-reach areas typical of rural environments. In this video, you learned that WPANs use IEEE 802.15 for nearby devices. WLANs use IEEE 802.11 for home or office networks. WMANs use IEEE 8.
Welcome to Protocol Table. After watching this video, you will be able to explain the difference between TCP and UDP, describe the relationship between ports and protocols, and list common protocols and their uses. A network protocol is an established set of rules that determine how data is transmitted between different devices in the same network. Network protocols are typically created according to industry standards. There are thousands of different network protocols, but they all perform one of three primary actions: security, communication, and network management. Ports are the first and last stops for information sent across a network. A port is a communication endpoint. A port always has an associated protocol and application. The protocol is the path that leads to the application's port. A network device can have up to 65,536 ports. And default port numbers do not change. Transmission Control Protocol, or TCP, and User Datagram Protocol, or UDP, are two primary Internet protocols. TCP guarantees that sent data makes it to its intended recipient. It's slower and requires more resources. Typical applications include File Transfer Protocol, or FTP, web browsing, and email. UDP doesn't guarantee that all packets will arrive, but it's fast and requires fewer resources. Typical applications include live streaming, online gaming, and calls over the internet. Ports send and receive data using TCP, UDP, and sometimes both. Web page protocols control access and connection between internet users and the sites they visit. Hypertext Transfer Protocol, or HTTP, is responsible for standard internet or web page access. The default port for HTTP is 80. And Hypertext Transfer Protocol Secure, or HTTPS, is responsible for encrypted internet or web page access. HTTPS should be used on a web page that prompts for sensitive data, such as credit card numbers. The default port for HTTPS is 443. File transfer protocols control how data is managed when sent from one location to another. File Transfer Protocol, or FTP, is responsible for file transfer. FTP transfers files to and from an FTP server or client. The default port for FTP is 21. And Secure File Transfer Protocol, or SFTP, is responsible for encrypted file transfer. The default port for SFTP is 22. Remote access protocols enable device control from a remote location. Teletype network, or Telnet, is used to remotely control another device via console or command shell. Telnet lets users configure network devices from almost anywhere worldwide, so long as both devices have network connectivity. However, Telnet should not be used due to data being in clear text, no encryption. The default port for Telnet is 23. Secure Shell, or SSH, is used to remotely control another device via console or command shell securely with encryption. SSH uses encryption to secure remote data. The default port for SSH is 22, which is the same port that SFTP uses, since they both offer similar secured services. And Remote Desktop Protocol, or RDP, is used to remotely control another computer via a graphical user interface, also called GUI or GUI for short. Email protocols determine how email messages are received, stored, downloaded, removed, or retained. Post Office Protocol version 3, or POP3, is an older protocol that was the standard for receiving email. With POP3, email is downloaded from an email server to a single device, and then the email is deleted from the server. The default port for POP3 is 110. Internet Message Access Protocol version 4, or IMAP4, is a protocol responsible for receiving email. With IMAP4, email is stored on the server and synchronized to multiple devices, like laptops and mobile phones. The default port for IMAP4 is 143. And Simple Mail Transfer Protocol, or SMTP, is responsible for sending email. The default port for SMTP is 25. Network protocols monitor, control, and help the network locate, share, and transfer data. Dynamic Host Configuration Protocol, or DHCP, automatically assigns IP addresses to devices. The default ports for DHCP are 67 and 68. Domain Name System, or DNS, resolves or translates domain names to IP addresses. The default port for DNS is 53. Server Message Block, or SMB, enables sharing files and printers on the network. The default ports for SMB are 137 through 139. Simple Network Management Protocol, or SNMP, monitors the network. The default port for SNMP is 161. And Lightweight Directory Access Protocol, or LDAP, allows directory services to store and authenticate passwords, usernames, and accounts and share them over the network. The default port for LDAP is 389. In this video, you learn that protocols determine how data flows on a network. Ports are the first and last stops on a network. Ports send and receive via TCP, UDP, or both. HTTP and HTTPS are web page protocols. FTP and SFTP are file transfer protocols. Telnet, SSH, and RDP are remote access protocols. POP3, IMAP4, and SMTP are email protocols. And DHCP, DNS, SMB, SNMP, and LDAP are network protocols. Welcome to the Microsoft Windows Server Lab environment. After watching this video, you'll be able to navigate the Windows Server Lab, simulate real-world server management tasks, sweep between instructions and server panels, and apply practical knowledge while understanding the variations in Windows Server editions. You'll also be prepared to complete tasks within temporary lab sessions and use tools like the on-screen keyboard when needed. Now imagine being in charge of configuring a server for a large organization. That's what this lab environment offers, a safe place to explore and manage Windows Server features without any risk to a live environment. To get started, access the lab by agreeing to the honor code and clicking Launch App. Once the lab loads, you'll see two sections: the left panel with instructions and the right panel with the Windows Server environment where you'll perform your tasks. If you prefer, you can swap the positions of these panels by using the switch arrow in the middle of the screen. The lab might take 2 to 3 minutes to fully load, so be patient while the environment initializes. Remember that features in the Windows Server environment may differ based on the edition being used. If you're practicing on a local machine, some solutions might vary from those in the lab. If you run into trouble with your physical keyboard, no worries. You can use the on-screen keyboard by searching for it in the search bar. If the search function isn't working, you can access it through Windows Ease of Access in the Start menu. Lastly, remember that each lab session is temporary. Make sure to complete your tasks in one session, since anything saved won't carry over to the next. Let's recap. In this video, you've learned how to access and navigate the Windows Server Lab environment, swap between panels, use the on-screen keyboard, and handle temporary lab sessions. You've also learned to account for differences in Windows Server editions when practicing on your local machine. You're now ready to explore and apply your server management skills.